pounds of torque. Thing weighed in at over 2,500 pounds. It's a big engine. Okay, we're getting that same horsepower out of a little 5.9 weighing 2/3 that amount. Right? A little 5.9 in a motorhome is making 350 horsepower. Okay, half the displacements. Okay, so because of technology and changing metallurgy, higher combustion chamber pressures and temperatures, we had to get a more uniform standard clamp load across the head.
So especially since everything's aluminum now.
Yeah.
And aluminum is very critical.
Yeah.
About how you torque it.
Well, because they're doing this for lighter engines, less fuel, better fuel economy. And let's face it, that 1982 Big Cam 350 was bigger than a 60 Series Detroit, weighed probably a third more than that. I think its dry weight was almost 2,800 pounds dry, and made, on a good day, 325 horsepower. And that was.
I was talking about automotive too, because right now our Cummins are still all iron, cast iron.
Automotive, it's all aluminum. All aluminum. But your smaller, like VW motors, they're aluminum blocks with steel inserts. So, but because we're getting more horsepower from smaller engines, which we are now, our 8.9s are making every bit as much horsepower as the big 92s. Okay, they've got higher pressures, more forces are involved, so we have to have a better way of applying a uniform fit, if you will. And the way they do that is they stretch the head bolt to the point of it almost breaking. When a head bolt yields, that's the technical term for it broke. If I torque a bolt to beyond its yield point, it means I snap that bad bear off. Okay, this is not something you want to get in the habit of doing. Okay? So when we talk about the need for a uniform clamp load, you got to understand the pressures involved in this engine. Okay? It's not uncommon in an engine for cylinder pressures to reach beyond 2,000 pounds. So that means a total force of about 50,000 pounds can be pushing upward on just part of the head. So everybody thinks about the force on top of the piston. Remember, when this thing ignites, the piston moves down. So as the piston moves down, the force decreases. Well, the force on the head does not decrease because the head doesn't move. So I might have 2,000 pounds working on top of the piston, and that's not an uncommon spec. You talk to your diesel engineers, they'll say every time that piston fires, there's about a ton of pressure working on top of the piston. But the rest of that explosion, or that rapid expansion of gases, is traveling up against the head, and it could reach upwards of 50,000 pounds of force trying to push that head up. Okay? So the clamp load, or how tight I seat two components together, gets to be more critical the higher these pressures go. That was the problem with that beloved Chevrolet 5.7 liter diesel nightmare they built back in the 70s. They took a standard gasoline engine, took the spark plugs out, put injectors in it, took the distributor out, put a rotary fuel injection pump, and called it a diesel. Well, that block with its head bolts wasn't designed for the pressures involved in a combustion ignition engine, and it was pulling the head bolts right out of the head, or right out of the block actually, and blowing head gaskets. Because one, the head bolts didn't go far enough in the block, and two, the clamp load, because the head bolts were torqued considerably less on a gasoline motor, they didn't change the spec. The clamp load was not at the yield point of the bolt. The bolt was in its elastic stage, and we'll talk about that. So there's two different kinds of torque ranges you can put a bolt in. Okay? I can torque a bolt, usually when you get a spec that just gives you a value. Torque the bolt to 125 foot-pounds. Okay, that bolt is in its elastic stage. It can stretch and recover, stretch and recover, stretch and recover. Okay, I don't want a head bolt doing that. Thing stretches and recovers. That means my head is actually lifting up and settling down. So if I have my head bolts in an elastic range and I'm firing the engine, the head is doing this. Okay, at some point your head gasket's going to fail. Okay. Did everybody get signed in? Because I think Frank snatched, oh no, it's right behind you, okay, never mind. John, did you get signed in on the sign-in sheet? Okay, who was the other last? Darby? You get signed in?
That was the second one.
Okay, good. Everybody else got some. 8 bodies. Okay, cool. All right, now, how much torque, when I torque a bolt, I'm twisting the bolt, correct? How much torque is actually applied to clamping the two components together, and how much torque is lost due to friction? Second question, where does the friction come from? Let's answer that one first. I'm torquing a bolt and I encounter friction. Where's the friction coming from?
Dirt, soil.
Could be. That's friction not accounted for during the equation that the engineers use to determine how tight I want the bolt. Okay, we'll get back to that in a minute.
Contact points.
Name them.
The head of the bolt against whatever it's clamping and the threads.
Yep, the pitch to pitch, thread to thread. Okay, anywhere there's contact. Okay, exactly. So it's been said, and I have no reason to doubt it, that if I run a bolt in dry, and we'll talk about wet and dry here in a minute, 80 to 90% of the torque value that I'm given to tighten it to is lost due to, you named it, torque between the head and the component it's clamping, and thread-to-thread contact in the board it's threading into. Now, what you're talking about is the guy's reassembling a component and he doesn't clean the debris out of the threaded hole. And now, in addition to fighting the thread-to-thread contact and the torque loss up here, he's got dirt between his threads that are making it more difficult. Now, will that affect the clamp load?
Yeah.
Oh, absolutely. Absolutely. Now, what happens if I put a little lubricant on the threads and I put a little lubricant under the head of the bolt? Or maybe I got a washer and I put some grease on it. How does that affect the bolt? How does that affect my loss from friction when I'm tightening the bolt?
Probably less.
Much less. So, how does that affect the bolt?
What stretches in between them, right?
Stretches longer, stretches more. So, if I put some grease here and a little bit of grease here, or oil, or whatever.
What about like anti-seize?
And, yeah, they say anti-seize is a lubricant, sure. But let's say I use International Compound number 2. Now, if you've ever put together a Detroit, you'll know what that is. Huh?
White pasty stuff comes
Oh
out.
man, no, it's a grayish white.
Oh, it turns white later.
Yeah, and tell me about the smell.
It's
God, it's freaking horrible. And it's slimy like snot. And if I open a can here, I'll have that shit in my house at home. It gets every effing place you can imagine. Just because it's so nasty. Okay, it is literally slimy. Okay, so you put it on a bolt, and when you're assembling a 50 series or a 92, they tell you specifically International Compound number 2. So okay, let's say we put a little bit on here, and I thread this thing in the bore, and I start tightening it. Okay. Is it going to affect the clamp load? Yeah, I'll get more of it. Okay. Is it going to affect the bolt? Yeah, it's going to stretch. Okay. Now here's the question. If the OEM doesn't call for the threads to be lubricated, and I lubricate the threads because I just do, can I cause damage or a problem? What am I gonna? What possibly could go wrong? Yeah, there you go. Well, what could go wrong?
You're gonna blow ahead, guys.
How?
Because they're not gonna be tight enough. If you put lubricant on
It's going to be too tight.
If I be tight enough, how do you figure that?
it, because it's
No, hang on.
if you put oil on it, it's gonna make it easier to tighten. So it's gonna reach whatever you think the torque spec is.
I see where you're going. Yeah, keep going. I think I know where you're going with this.
It's gonna reach.
You're wrong, but I think I know where you're going with this.
Or
Well, no. But excellent school of thought, because a lot of people think this. I know where you're going with this. So it's going to be easier to tighten because of less frictional losses, so it's going to click sooner,
yeah.
right? Well, physically, yeah, you're right. It'll take less effort and it'll click. But because I'm not losing 80% of it to friction, the bolt is actually tightening more because it's stretching more and I'm getting more of a clamp load. You see what I'm saying?
Yeah.
Okay, and then the wrench clicks, instead of the bolt being that long, it's this long. Okay?
But wouldn't
Did that clear that up?
Yeah.
But
Okay.
like he's saying, wouldn't it cause a problem with it being lubricated, having it coming loose easier than it would be?
Possibly. But depending on the clamp load and pressures that we're dealing with, it may come loose easier. If you're torquing this thing at 288 foot-pounds, I doubt it. Okay, I doubt it. Oh, don't get me started on that. We had a dude, when I was in Long Beach, he put a new head on an engine and he put Loctite on head bolts. That motor actually got discarded. We couldn't separate it. We couldn't separate it. It chunked a rod. So we were gonna pull the head off, pull the piston out, just put a liner kit in it, no big deal. So the dude, I feel sorry for it. I remember it was Tommy. It was Tommy Connors, big bull of a guy, just huge guy. So he's got his breaker bar. He's going to loosen up the head bolts. Now for him, that's no big deal. The guy's very strong. So he puts the head bolts on it. Snap. Oh, son of a bitch. So he says, okay, I can get one out. I'm standing next to him. He used to talk to himself, and he'd have some bitching conversations with himself. I thought he was freaking lying. He's like, yeah, it's no biggie. I can get one out. I'm like, what's that, Tommy? Nothing. Okay. Snap. Oh, this sucks. So you gonna keep going with that? Yeah, man, we're good. Okay. Snap. That's 3 in a row, and I'm like, dude.
Are you going the right way?
Well, no, because this guy was considerably larger and much stronger than me, I didn't want to make him mad because I could tell he's getting frustrated because he's sitting. I know when he's getting mad because he's doing this on his box. I'm like, Tommy, what's up? Fucking motor don't like me. Okay. Didn't know they had a personality, but. And the faster they went, the madder he was getting. So I said, why don't you go talk to Lee? Maybe he can help you out. Yeah, that's a good idea. Good idea. Goes booging over to the supervisor. Lee comes by and says, take them all, Tommy. Take them all off. Tommy's like, I was like, oh, this is, I actually stood back because I didn't want to. So he's like, snap, snap, snap. He just, son of a bitch. I says, Tommy, the head's going to come up really easy now. Screw you, Tingley. Like, whoa. So he pulls the head off. We send it out to a machine shop to get these things out. They actually lasered them out. And we get a call. There's a machine shop in San. Who's the dumb fuck that put a Loctite on your head bolts? Ooh, crap.
Extra red,
I don't know what color it was. I think it was the one below it. Blue?
blue. Blue usually ain't that bad.
Yeah, but on a head bolt?
Yeah.
I mean, and Tommy he's like, snap, screw you, snap, yeah, right on, snap, showed you, snap. And I was like, oh, he's losing his mind. Somebody get the lithium, man, and give him a couple taps. He needs to dial it down a bit. But, so when you're using Loctite, use it at the discretion of the OEM. Okay, if they say apply a sealant or a locking compound, then yeah, go ahead. On critical applications like that. Same thing with putting oil on it. If I oil a bolt and I torque it and that bolt goes from elastic to yield, that might not be an application where the bolt is put into that range. And we'll get into that here in a bit. Some clamp loads require there be a certain amount of give because of the nature of the clamping, like a water pump to a block. You normally torque those to about 40 foot-pounds. Because I need that bolt to be able to give a little bit because of the vibration of the engine and the fact that I've got a side load on a pulley, right? So, but if I were to put those bolts that hold the water pump onto the yield limit and then put a side load on the pulley, I could very well break the bolt because it's already at its maximum stretch. And now I'm going to put a load on the pulley and force it to go do this and snap the bolts. You see what I'm saying? Now that doesn't mean every time you put oil on a bolt and you're not sure if it's supposed to be there or not, you're going to break the bolt, but I'm just saying the possibility increases. Okay? So we get to the age-old question of well, why do I torque things and what exactly am I doing? What is torque? Now torque, again, torque in this application is different than when we're talking about the torque output of a motor. Because we apply a torque to a bolt to get a certain amount of clamping force between two components. So torque is the amount of force that is acting on an object, causing the object to rotate on its axis. That's an engineer's version of torque. They're talking about rotating a bolt. Okay. Now, when a bolt is initially tight, the bolt will stretch. And the bolt will continue to stretch for as long as the bolt is turned in the threads. That's kind of a no-brainer. I put a bolt on one component, second component, and I turn it. The threads are actually mechanical advantage, the two threads, the pitch, the angles of the threads. They will continue to stretch the bolt until either I run out of hole, I bottom it out, I stop turning, or I break the bolt. Or if I'm tightening this, this starts to collapse and give way, which can happen. So, threaded fasteners are generally used to clamp two or more components together and acting as a heavy-duty spring. Now, here's what that means. Most torque values today, even in our work today, the bolt is torqued to a single value. Torque the bolt to 75 to 90 foot-pounds. They'll give you a range. Okay? So I run the bolt down 75 to 90 foot-pounds. It's still in its elastic range. So it's going to give a little. Acts like a spring. Some applications, that's exactly what we need. And if I remove the bolt from that application, it's going to retain its original dimensions. Okay? Now, that doesn't mean I can use that bolt indefinitely.
On that, I have a question on that one. When they have the range between those two, is it better to go right in the middle or all the way to the max? 'Cause a lot of people go to the max.
I was always taught to
Say
go
two-
to the middle of the
2 to
range.
300.
Yeah, I was always taught to go to the middle of the range. Okay? And the guy, it was an old veteran mechanic, and I remember this today. He says that way you get the tightening that you need, but you don't max the bolt out.
Yeah, but then what if the guy before had already maxed it out and now you're putting it at halfway?
And the bolt's stretched.
Well, and that's a great scenario. I'm glad you asked, because I was just about to answer that. The bolt does not have, because it's in its elastic range and I'm not deforming the bolt, it still does not have an indefinite life. It has a finite number of cycles of stretching and recovering before it suffers from fatigue. And then you get fatigue failures. You're like, well, how can the bolt fail? Well, it's only torqued to 50 foot-pounds. Well, it's been there for 9 years. It's been doing this for 9 years. And at some point it fatigued. Then you have to figure also, depending on where the bolt's located, I'll have two dissimilar metals, and if it gets wet, I've got electrolysis sitting in there, eating away at the bolt.
89s all day.
Okay? So, to answer your question, you don't know when it's going to fail. You don't know that, you know, okay, the last guy used it, and it's in the bin to reassemble it, so I grab it and I reassemble it, and I torque it back, and it torqued and everything's fine, and then it goes down the road and springs a leak 3 weeks later. Well, is that improper assembly on your part, or did the bolt fail and you lost the clamp load at that particular part of the component and it leaked? Okay? So that's kind of a conundrum we're in. Do I replace the bolt? If I got my bolt then and it's not a specialty bolt with specialty materials or whatever, I probably would. Because like you said, unless you know how long that bolt's been in service, hard to say.
Maybe like the hub bolts, we usually reuse them until we put new calipers on.
You can.
But some of the guys, those after models are done.
See, I'm not a big fan of impacts. I mean, they're great for disassembly.
Yeah.
They're wonderful for disassembly. And when I use mine, I use them to run them down but not torque them. I know guys that will go and then click. Now, there's a couple of problems with that. Well, so what are the problems with that?
You were tying it.
You probably did because the wrench clicked.
So it's
Oh, so it's at 288. Well, I don't know. I mean, if I set it to 300, is it still going to click? 350, is it still going to click? 400, is it still going to, I don't know. If it turned a bit and then clicked, I'm good.
Yeah.
But he's like, "Rah, tat, 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 tat." Click, yeah, 288. No, the correct statement would be at least 288. Right? We don't know. Okay? At least 288. Now, again, my opinion on impacts is my opinion. Okay? If you use your impact smartly, it'll make a lot less work for you. If you do it correctly, you'll get it done right. So some guys will run, done, okay, and click. There's no problem with that. That's absolutely fine. It's a labor-saving device for a reason. But it's not a substitute for proper torquing. You see guys get on a torque wrench, and like I mentioned earlier, and they're torquing it, click. Okay, somewhere in that 60-degree arc, your wrench clicked. Well, yeah, but it kept going after it clicked. Click. Whoa. So that's 60 and 48 degrees. That's not 60 foot-pounds. So what state is my bolt in? Is it torque yield or is it still elastic? Well, it's tight. Well, tight's pretty vague. And when I was on the floor, you'd get it. Well, click. What's the problem? Well, there's a lot of things here. So let's say you're doing head bolts, and you're not really paying attention, and it's click, 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 click. Do you have a uniform clamp load? No. You got one of these things going on. Now, is that going to help your head gasket?
Yeah.
For a while.
Can help it fail.
Yeah, that's kind of where I was going with that. Okay.
I got a question for you. As you're just demonstrating there, when you hit that torque spec, do you continue with the 90 on that, or do you take another wrench and take it from there to the 90?
Good question. That's an outstanding question. So I've got a torque spec of 90 and 90, let's say. I go down here, click, and I stop. I take this off. I get my breaker bar. And I continue. Because you're thinking, well, 90, how hard is that? Yeah, no. It's like 90 and you're like, I can easily damage the wrench. Okay, same thing with loosening a bolt. I'm taking off all these hub bolts at 288 foot-pounds, right? On your new flyers for the Excelsiors. I don't grab the damn torque wrench. It's not meant for loosening stuff. Well, yeah, it is, Mike, because it's got a thing here that says off. I says, no, stupid. That's for torquing left-handed bolts, or getting you there and then torquing.
So I've used a torque wrench to do that, but not this one. The one with the needle. Like if I don't know what the torque is on it and I'm taking it off, I'll just unloosen it and watch the needle until it gives, and then
you stop.
yeah.
Okay, that's not a problem. What damages the wrench is when and it loosens up and it does that. It springs free. That's what damages the wrench. If I'm reverse torquing, and the needle starts to move, there's still some friction on that bolt and that clamp load. There's not a sudden release of friction, a sudden release of torque, and then the bolt breaks free. That's the part that damages the wrench. More so the spring-loaded guys than these. I'm quite sure it's not good for these either. Okay? But if I have, and that's a lot of reasons, if you don't know a spec, you can't get it. But one of the ways you can do it is you get a wrench and you set it, okay, 100. Nope. 125. Nope. 135. Nope. 150. Click. Okay, just started. It clicked at 150. Okay, that's what I'm going to put it back to. Then you put your torque wrench down, and you get your breaker bar, and you finish. But if it's, oh, I'm too lazy to go to my box. Oh, look, Israel's wrench. Yeah, hey, let's go get some coffee. Well, he's gone, and I'm breaking bolts loose with this thing. I'm like, okay. That's how I left it. Oh, wait. And I walk away, right? He doesn't know I just broke 10 axle hub bolts with that loose. He's like, oh, okay. Right? You've seen guys do it, I know you have, everybody has. What do you do with a torque wrench? Oh, I'm breaking a bolt loose. Yikes. Okay, fine, have at it. What's that?
Happens everywhere.
And, and I did it in my rookie days because I didn't know any better. I'm sure everybody has. If well, I've never done that. You're lying. You're lying through your teeth.
I didn't do it.
I had the unfortunate.
They had already told me, don't ever loosen anything up with the torque wrench, so it's fine.
Well, and when I started in Long Beach, I worked with some questionably skilled mechanics. Polite way of putting it. And actually an auto shop. I took auto shop in high school back when I had shop classes. And I had a torque wrench and I was breaking lug nuts loose on a sedan, and my auto shop teacher's like, hey man, that's not what it's for. It's like, oh, okay, you'll damage the wrench. Oh, okay. You learn. But it's when you know better and continue to do it, that's when you're not a professional. You're just plain old lazy, man. And it's usually not his wrench, it'll be the shop wrench. So the next guy gets it like you, and you got a set of spec, and you're like breaking bolts. You're like, what the hell? Well, the wrench isn't calibrated. Because we send ours out, if you look, yeah, we send them out every year to be calibrated. In fact, right now, mechanics can't use their own wrenches. They've got to use the shop wrench. Now, I got issues with that. Because how well does the mechanic treat the shop wrench? Probably not very.
A lot of things can happen in a year too.
Well, sure.
They fall, huh?
Well, they fall, or the guy doesn't reset the thing. He hangs it in the cabinet, and it doesn't get used for 3, 4, 5, 6 months, whatever. Whereas if I laid out $1,000 for this thing and it's sitting in my box, I'm gonna take care of it. It's like how well you take care of a rental car, right? I rest my case. You would throw your car in reverse on the freeway. Well, maybe, I don't know. Okay, now. So the total scope of a job of all the components being clamped together is a bolted joint. Okay, they've got welded joints, they've got riveted joints, they've got all kinds of joints. This is a bolted joint. It's meant to be serviced, taken apart and put back together. That's why it's bolted. Okay. So when you thread a fastener, either with a nut or you thread it into a bore, preload is the state of the bolt's tensile load, the stretching of it, the preload of it, okay? And its capacity to withstand being pulled apart. The clamp load is the state of the joint's compressive loads as the two components or as its capacity to withstand loads being pushed together. It's the pressure between the red and the blue. That's my clamp load, my clamp or my joint's compressive load. These are engineer terms, but I think you get the picture. Okay. So, as stress and strain increase, the fastener will eventually reach a limit and fracture. You broke the bolt. Okay. The yield strength of a fastener is the point of stress which the material it is made of starts to deform permanently. Okay, so now, if you've ever looked in Cummins, like if you buy a rebuild kit for Cummins, there'll be a template, a plastic card, or I guess it's cardboard now, a cardboard card, and it'll allow you to take your head bolt and put it against the card, and if it's too big to fit in the groove, the bolt is stretched too far. And they'll tell you minimum diameter for reuse is 0. whatever. If it's below that, that means it's stretched and it's necked down. So necking down is like I gotta make my disclaimer about not being an artist. So my wife bought 5 boxes of Girl Scout cookies.
You didn't bring them?
Tag
Well, I
along.
was gonna say, guess how many I got?
Crumbs.
Tag along.
Her and her boy ate them, and they got Thin Mints. I like Thin Mints. That ought to be against the law, man. Tag-alongs are good too. Those are good. So if I torque a bolt and it necks down, Now that's kind of exaggerated, but that's exactly what happens. You'll get a thin spot in here where it's deformed. Now if the bolt's in its elastic stage, and I loosen it up, it recovers to its original dimensions. The original diameter throughout the shaft and the original length. When I torque it to yield, I start approaching the maximum tensile strength of the bolt, it's not going to recover. And that's obviously dramatic, but I mean, if you take a head bolt off of the Cummins after it's been in service, and you put it against the template to see if you can reuse it, and I put my bolt on here, and it stops before the end, as long as its diameter is in spec, I can reuse it. But if I put the bolt in here, and it extends beyond the card, it doesn't come up flat, it's too long. It's been stretched too far. It's like, if I try to install it again, I'm courting disaster, because it's probably going to fail. If it doesn't fail during installation, it'll fail at some point when the engine's running.
So you just can't cut the tip and then reinstall it?
That's the first time I've heard of it. Well, we just cut off about half an inch, it'll fit right up in there. Only, don't cut this end.
Of course.
Cut the thread it in, and then put a little chamfer on it, and dress it up on the grinder. Hey, here's brand new bolt. You know, I don't think someone hasn't done that. Or maybe you have, that's why you know about it, I don't know.
I've cut it before.
Yeah?
Not after.
I ain't buying any used car. I ain't buying any used cars from you, man. You're freaking dangerous.
So one other thing I've done too, it's probably not a good idea after listening to this, is straightening a bolt.
Yeah, no, that's
If
not
it's
good.
bent and then straightening it.
Well, that all depends. That all depends. Are you selling the car?
Well,
It's not his.
Okay, yeah, no, don't do it then. Yeah, it's my ex-wife's car. Oh, I'm fine, have at it. Especially if it's a caliper bolt, right?
Was it a camber bolt?
Oh, nice. Yeah, no, straighten up, not a good idea. Not a good idea. How'd it get bent?
just dropping it, still being attached to.
Oh, okay. I was like, you dropped the bolt and bent? I'd be wondering where I got my bolts at that point. Because about 4 years ago, we got a bunch of counterfeit grade 8s. Golden West Fastener delivered a bunch of bolts, and our guys were putting them in and snapping them off at a very low torque range, and we're like, what's the deal? You know, one mechanic, you're like, it's just nut loose behind the torque wrench. But when you got a whole shift over a period of time snapping these grade 8s, so we grabbed a bunch out of the bolt and we sent them into a lab, and the meddler just like, this isn't even good rebar material. We're like, holy crap. So we called Golden West and we told them what was up, and we sent them a copy of the reports, and to their credit, they came out and took all of our bolts out and resupplied us free of charge. That's a couple of grand to them. And then they went back and investigated where they got it from, and it came from China. They got the coronavirus off of them. I'm glad they call it the coronavirus, because you imagine calling it sick, yeah, boss, I got the Bud Light virus, you know, the Dos Equis virus. Dos Equis virus would have been cool, though. That'd have been a good name.
That's next.
Huh?
That's next.
You know, if they're naming diseases after beer, I'm okay with that. How'd he die? Well, he got that dreaded freaking triple X beer. That's a rough way to go.
Hard seltzer virus.
Yeah, see, that's kind of wimpy. Hard seltzer? That's like, how did you die? Oh, I died from the Spritzer virus. Really?
Truly.
Right? Spritzer. I died from the Shirley Temple virus. Where's my little umbrella?
Yeah, so they just posted those signs in our base now saying that, you know, what the signs are. They told us that we're not allowed to wear a mask while we're driving.
You're not allowed to?
No.
Well, that's stupid.
I know, right? Why warn us and then tell us we can't wear a mask?
Well, you know why? So now you know what to call in sick with. Well, I've got fever, coughing, itching, foot itch, throw in a couple of extra, like rectal inch with it. That sells it right there. Oh crap, you're recording, I gotta be good. I'm like, why post a description? Because that's what I'm writing down on my phone. Let's see, Lindsay Moss. You heard about those poor guys on that ship off of Okinawa? They were quarantined for 14 days and they flew them back to the States and they're quarantined for another 14 days. So your 1 week vacation just turned into 1 week and 28 days. That sucks. Now, so yielding permanently deforms the bolt, kind of like me. There's no fixing this, man. This is it. One day a year, I don't have to worry about it. What day is that? Halloween. Just saying. Now, proof load of a fastener is its usable strength will return to its original shape. We call it the elastic limit. The proof load is torque it to 68 foot-pounds and leave it. Okay? Now, how would you know if you've got a yield spec? It usually involves turning the bolt an additional degree after you tighten it to the spec. All right? So, for example, our Cummins, the head bolts are torqued down in a 3-step sequence. And one of the last steps is to apply an additional 90-degree turns after the final torque. Okay? That tells me that that bolt is being twisted to its maximum yield limit, meaning it's approaching its break point. When something yields, it breaks. Follow? Okay. Proof load of a fastener is its usable strength will return to its original shape. So after I torque that bolt to 80 degrees and I take it back out, it's going to look, if I measure it, it's going to be the same length, same diameter,